Hi Anna, this is your feedback for the test we did in class. 42 out of 58 is a fantastic result given it was a very long test and it wasn't really very well prepared. Okay, so in question one, the Harper swimming question, be careful with your domain, you can't equal negative infinity, but apart from that everything else there is correct, except please label your y-intercepts. Took a mark off for that. It's not really northwest. You can show an arrow to indicate the direction of movement in preference to saying northwest because it's not really northwest. The gradient would need to be -1 for it to be a northwest. Question number 2, 3 marks, all very well done. Question number 3, 4 marks, really well done, except the last question I mucked up. And I didn't take any marks off because I only made it worth 1 mark, but its starting position was not 0, 0. So the distance from her starting position to this position isn't just this, because they actually started, her starting position was -328 on 3 and 13. Therefore, we went from here to there. But I probably should have had the starting position 0, 0 because the numbers ended up pretty awful for the amount of marks that were there. Question number 4, it's the projectile question. You didn't really do any of this question. You prioritised your time elsewhere. So maybe work through this at some point. For this show that, you can't use this information in the show that. You need to start with this and take an antiderivative, and then your knowledge about VO will be, if that's theta, VO will equal V cos of theta in the I plus V sine of theta in the J, and then for when you plus your C, you can use that information. And because you didn't have those formulas, you couldn't have done any of those. Question number 10. Okay, so these are looking very much like straight lines. So be really getting a little bit more trigonometric curve in those graphs, please. But that's correct, the graph's correct, that's correct, the graph's correct. 25 is correct. And I think that it is never travelling out of constant velocity because the velocity is always changing. I would be looking for a horizontal line. I'd also be getting an expression that had no t in it. Question number 6, fantastic. Question number 7, really good. The only issue that I had was you can't introduce a t when you're wanting it to do with x. So you need to use a equals v dv dx. You have v, take its derivative, and then substitute that for dv dx, and then multiply them together. Question number 8, running out of time. You didn't take this derivative properly, so therefore you weren't going to get a constant. Over here, that's correct. There's your working out for the rest of that one. So really, really good. I've made the solutions available on the website for you. Well done.